so let's get going. It is time to start, right? Yep, 3:15, around the nose. All right, so thanks for coming. I appreciate the opportunity to come and speak to you today. My first time in Australia, and I'm having a great time. So I appreciate you coming to this session. It looks like a lot of you have Azure experience. This session, just to get the disclaimer out of the way, this session talks about how to scale your cloud database. So how many are you familiar with the SQL Federation stuff? A few of you. Okay. This is not SQL Federation. Okay. This is how do I scale and apply design principles to scale my database from A to Z. Okay. A lot of SQL Federation fits specific scenarios. This is, hey, if it doesn't fit for me and where the future of Federation goes, this is how do I, the same design principles, a lot of the concepts still apply to however you scale your database, right? Whether it's on-prem or in the cloud. This is particularly in the cloud. But how do I design and scale my database using the same principles? For example, if I need to partition, what do I partition on? What tables do I need to include in my partitioning? Things like that, right? How do I partition and grouping and things like that, right? So this is what we're going to talk about today, is how do we do this? And I don't want you to get caught up on, this is just a work in progress, and this is not what we're going to talk about today. This is not Microsoft gospel. This is not, hey, you must do it this way. This is things to think about, concepts, principles. This is, if I'm going to do this, how do I apply these principles, right? So if you look at the UI and go, holy cow, that's ugly. Okay, don't get hung up on the UI. This is, here's how you do, like one of the things that Federation lacked was fan-out queries. Well, we're going to talk about how to apply principles to do fan-out queries, right? Quite easily, in fact. So a lot of these principles, it's just, don't get hung up on the UI, don't get hung up on some of the semantics. These are, again, principles and concepts, okay? All right, so quick introduction about myself. So there's my blog, email, and Twitter. So if you have questions about what we discussed or want more detailed information, reach out to me, and happy to chat more, right? So what are we going to talk about today? So scalability in general, right? Kind of a quick overview on scalability, scale up, scale out. We'll look at the architecture, these are the principles and concepts you need to think about when designing for scale in the cloud. We'll look at some of the management, how do you manage some of these concepts, and we'll actually look at this as far as the tools and utilities. And then some best practices you need to, what key do you pick? What data type do you pick? Things like that. Okay, we good so far? Excellent. So I like to keep these interactive. I don't like to do all the talking, so if you guys have any questions as I go along, man, feel free to raise your hand and let's go. This is more of a interactive session, okay? So feel free to interrupt any time. All right, so the goals are, what we want to do is explain the importance of database scalability. So these are the three things that I want you to take away from this session is, what are the goals, the importance of database scalability, what are the components and principles and concepts you need to think about as you're designing for scalability, and then we're going to just demonstrate, got a few demos, we're going to demonstrate on how to apply these principles and concepts, right? All right, so let's look at scalability. So what is scale up? Yeah, basically, so on-prem, how do you scale a database? Yeah, you just throw more CPU and memory to a machine, and at some point it just, you've reached its limit, and then you go, crap, I got to get a bigger machine now, and you like, buy a bigger machine, and then that hits its end when you throw more hardware and CPU at it, right? So at that point, it's hard to handle a peak load, and there's some limitations around the scale up. You're just throwing more hardware at a problem, and you're not solving the problem, right? So this is scale up. Scale out basically says instead of throwing more hardware at the problem, we're sort of doing that, but we're going to throw more hardware in a linear fashion, right? Let's take that database and partition that database across multiple physical nodes, right? So we can do that in Azure because we have commodity class hardware, so we can just spin things up as we need them, right? So sharding and horizontal partitioning. This is when we take my database and partition that across multiple physical independent nodes. The great thing about that is what? So if I, from a scale-up perspective, I just bought I just spent a lot of money on a piece of hardware. In the scale-out method, in the scale-up, then I've just spent all that money, then that's money I can't get that money back. In a scale-out perspective, the whole concept around this is elasticity. Let me scale up and scale down based on demand, and that's really difficult or near impossible to do in a scale-up scenario. But in a scale-out, I can elasticity, right? Scale up, scale down, then get the partition, the nodes that I need, and then give them back, and just pay for the resources that I use. Okay. So, given that, then this is the scale-out fits the cloud applications better because if you're selling the greatest thing since sliced bread in an on-prem scenario, you have to guess. Well, it's going to be it might be the greatest thing since sliced bread. So let me buy all that hardware. Well, Mother's Day is coming up or something like that. So you got to buy all this hardware and hopefully have enough hardware, and then you have to order more. So the hardware provisioning and scalability from a scale-up perspective. It's difficult to match the patterns of a cloud economics, right? Because then if I have all this hardware and then it's the middle of July and nothing's going on, I have all this underutilized hardware, correct? And I just threw all that money away. But in the cloud scenario, I can scale up and scale down. Right? This is the scale-out scenario, so just elasticity and pay as I go. And this is the concepts we want, right? However, there are some challenges around designing for scale in the cloud, and there's a few, right? So what's the tenant? What am I partitioning on? Am I partitioning on customer ID, order ID, customer name, order date? What am I partitioning on? What's the key that I'm doing? And am I doing, what's my shard strategy? Am I doing a range? So am I doing like 1 to 10 in this shard and 10 to 20 in this shard? What's my range? How do I do splits and merges and tenant moving? So if I need to take this one tenant from this database and put him in his own shard, how do I do that? How do I scale back? How do I handle identity conflicts if I need to scale out, if I need to merge, right? How do I handle that? And then transit nature of connectivity, right? So there's every time you're dealing with the cloud, what happens if, from a connection standpoint, if my connections drop, generating IDs, things like that. So there's and then overcoming limitations of existing tools and available features. So do I need to recreate their wheel? Is there anything out there that I can use? Do I have to learn a whole new set of technologies, things like that, right? So there are challenges with scaling in the cloud, and scaling in general, right? So how do we overcome these, and what's the correct principles and concepts we can apply to overcome some of these? So we understand scaling from an application standpoint, right? Any application developers in here, right? Most of you SQL people. Where's your SQL people? Okay, a few of you. Don't be shy. Raise your hand. You're not bad. Yeah, woo, right here. All right. So we understand scalability from an application standpoint, right? If we need to scale the data layer, or the web layer, right? We create more instances, right? We write this great app. We open the floodgates, and if we need to scale, we throw more instances of the front-end layer. We load balance those, right? Same thing with the middle tier, right? We can do the same thing and throw up more instances of the middle layer. How do you scale a database? That's why you're here. That's right. Thank you. That's why you're here. Good answer, right? Yeah. Wouldn't it be nice to basically say, let me apply those same principles that we apply to the application layer and the data layer to the database, and say, I need more instances of my database. So give me 10 more nodes, and then when I'm done, give those back, right? So this is what sharding really is. This is the ability to say, let me apply those same principles that we apply at the front end and the middle tier to the database layer. Let me scale up and scale down based on need, okay? So why use database partitioning, right? So again, same principles. I want to go from 1 node to 10 nodes back down to 1 and just pay for the resources that I need. Harness the ability of SQL Azure, right? So in Windows Azure SQL Database, we've got all these servers out there, and let's use those resources, right? If I need to go from 1 to 100 and back down to 1, let me do that, right? Best economics, simplified multi-tenancy. And the whole concept between sharding and database partitioning is to be able to say, multiple tenants per database, or a single tenant per database, or multiple databases per tenant, right? From one end of the spectrum to the other. The whole concept behind database partitioning is I should not be confined to a single concept. I should be able to have multiple tenants per database, and if I need to, take one tenant out and scale that to another tenant. okay? Because this guy may be causing problems. He might be taking too many resources on a box. Let me pull him out and put him on his own box or his own database, right? Same thing with multiple databases per tenant. I've got this one guy. He might be going outside of it. I may need to, because he's my biggest customer, I need to spread him out across multiple databases, for example, right? Because again, what's the biggest database size in Windows Azure SQL Database? 150 gig, right? So if I need to, if this guy's getting bigger, maybe I need to partition him across multiple databases, right? So some of the concept. All right, a few examples. So web scale database solutions, multi-tenant SaaS. There's, the whole concept around this is that we're not pigeonholing you into a specific vertical. If you've got high transaction systems, SQL applications, this database partitioning, sharding schematics apply to all concepts. So let's take a few minutes. Any questions about that? Good so far? Okay. So let's take a look at the architecture and make sure we get some of our language and jargon right? We need to make sure why, and this is why we spend a few minutes up front, the reasons for scale out are understood, right? So the platform is Azure and data store and SQL database, right? So and a lot of these principles apply to on-prem. So we're talking about in the cloud, but this also applies to SQL Server, right? We're going to talk about a workload group. This refers to a particular workload or a function or vertical partitioning, right? So think of these as a boundary. Right, we're going to take some databases, and we're going to have these shards in a particular workload group. We're going to call these a boundary. These are all work within a specific group, and they're all tied to our shard. Right? Shards refer to a single data store. So think of this as every database is a shard. Right? And range partitioning. So database 1 may have 1 to 100. Database 2 may have 101 to 200. Things like that. So shard refers to a physical database. Okay, elastic scale out, we're not going to rehash this. This is just the ability to scale out and scale back as we need to. Go from one node to 100 nodes and back down, okay? So there's range sharding and point sharding. Range sharding refers to each shard covering a range shard key value. So again, 1 to 100, this is a range. Could be negative 2 billion to 1 to 2 billion and things like that, right? So it could be a range depending on how many partitions you have. Okay, we're not going to talk about point sharding, but this refers to the case where shard has no shard key. It's just, we didn't pick a shard key, or what they call the federation key. It's just, point sharding. We're not going to talk about that. We're into range sharding. All right, so let's talk about some of the architecture, about how these are, some of the concepts you need to think about. And a lot of these, if you're familiar with SQL Federation, some of these are very similar, right? But we're going to talk about this in terms of not SQL Federation, because how do I take a database and apply that and scale that out, whether it's an existing database or a new database. So we have what's called a configuration database. Whoop, that's right there. And then a workload group and shard. So my configuration database, this contains the shard map and configuration metadata information. This is low volatility. This means that we are not hitting this very much. This just contains metadata, right? This just, where are my shards? Where's my shard map? What is my configuration settings? Some metadata. This is not a high volatile. This is not a high transaction. We are not hitting this very much, right? We don't want a bottleneck, right? We don't want to be hitting a database every time we need to find out where to go. Does that make sense? Right? This is just metadata, okay? We then what's called the workload group, and we saw this earlier. This is basically the boundaries of contains the boundaries where my shards live, okay? This contains things like how many shards do I have, what are the max number of shards, what servers can I shard to, right? I don't have to have just one server. But can I spread my on-prem scenario? Can I spread my databases across multiple physical servers, right? So the workload group says, hey, this is a boundary for all my shards. Does that make sense? Okay. Then we have the shards. These are the physical databases themselves. Now, these are not system managed. These are managed by you, but they're still managed by the workload group, and they're known by the configuration database, right? But when I say known by the configuration database, that does not mean that we're going to the configuration database to go, I need to go here. Okay, we good with that? All right. So we then have what's called the tenant key. This is, what am I partitioning on, right? Again, customer ID, order ID, right? We have reference tables. Oops, I think there's a copy-paste error. There's reference tables. These are things where, again, these are fairly static. These are things like state, zip code, things like that. These are tables that you're not updating very often. These are tables where you could do, where fan-out queries apply. So if I need to, I want to insert a new state into every shard. This is where fan-out query comes into play. I don't want to have to execute that query against every shard one at a time. Let me execute a fan-out query against all those, right? These are fairly static tables, right? Yep, there's a copy-paste error there. All right. So some key concepts around, two key concepts around sharding, right? Dynamic partitioning, right? One of the things that we're going to show you, in the demo is, we want the ability to say, if I hit a threshold, right, and we'll see this in the demo, if I hit a threshold, or whether that threshold is, I've reached the max number of shards, I've reached the max shard size, things like that, I want to automatically, dynamically repartition my database, okay? I don't want to have to get an error and go have things come to a screeching halt because I've hit my limitations for whatever reason. Okay, so in this scenario that says I want to be able to split members dynamically and split those workloads across multiple independent nodes. Okay, and let me do that dynamically. I don't want to have to do that manually. I can do it manually if I need to, but let me do it dynamically. Right, and then if I need to, I can go back and say, all right, my load is back down, so let me merge back into from 10 to 5 shards and things like that. Right. So any shard strategy should be able to have the capability of dynamically partitioning. If I hit a limitation, whether it's by size or max number of shards, things like that, let me dynamically partition. Create another shard for me, and then send the new data to that shard. Make sense? Okay. All right. Reliable routing. So again, this is important. At any given time, again, without going to a specific database to go, where do I need to go to get this data? I should be able to, at any given time, know where my data is. Okay, so if I need this user ID, I know it's over here. If I need this user ID, I know it's over here. At any given time. So a lot of these principles apply to what you're familiar with in SQL Federation, but these same principles should apply here, right? Guaranteed member routing. If I'm looking for this specific record, I should know at any given time where that ID is. I shouldn't have to go anywhere else to find it. I shouldn't have to go here, and I shouldn't have to go to another database to go, where's this ID? Go over here. Does that make sense? I should know where it is at any given time. So with that, let's jump out and spend some time in a demo and looking at some of the configuration. Okay. All right. Okay. So what I want you to, so what I've got, I've logged in here on-prem, and these are my databases, right? And what I have here, I've got a database called JLA, and this is my configuration database. Okay. So notice I have no shards currently in my SQL database or in my on-prem SQL server. Okay. So what I have here is, this is kind of a sample. This is, again, a sample. This is some of the things that we've been working with the SQL CAT team about how to define and apply some of these principles to, okay? So things like workload groups, servers, partition across multiple nodes, things like that, fan-out queries. We're going to talk about all of this, okay? So let me run this. So notice I've got, it's quite filled out. There's quite I'm not going to go through all of these, right? Because I've got some testing projects and I've got some scalability projects and frameworks, right? What I'm going to do is run this, and we're going to walk through some of the concepts and principles about how to apply the things that we learned. Can you guys see that all right? Okay. No, people squinting back there. All right. So let me run this. All right. So I have, again, a very simple UI. From the management side, but it's going to apply some of the principles and talk about some of the concepts that we've talked about. Okay, so when this comes up, so any questions so far? We good? Excellent.
Sorry, one question. Are you going to show us just now how you would know where one particular entity is in which database?
Yes.
Is that something you're going to
yeah, from a query perspective.
Right.
Yeah, we'll get to that. Now, again, I just want to apply yes. So, but this is a very simple application. So this is, again, kind of a 100-level introduction on how you could define and query these, right? But this is, again, open for discussion because you go, hey, could we do this? So once we go through this, then let's chat about it. I want your feedback, okay? Tell me what you like, what you don't like, things like that. Because, again, from the disclaimer standpoint, this is, all right, you must do it this way. We're not saying that. Okay, we spent about the last 20, 25 minutes talking about some of the concepts and principles you need to understand, and here we're applying those, and they could be applied any way, more than one way. So the key here is we want to show how to do fan-out queries, how to look to see where do I go to get a specific record, right? A specific entity, you're asking, right? Okay, we're going to show you how to do that. But you could say, hey, could we do it this way? What about this, right? These are the things that obviously we want to talk about, correct? All right, so I've got a very simple console application. What I've done is, notice I've got quite a few tabs across here. So in my settings, I need to know where my database is. So I went through and said, all right, my prefix code, my shard user, shard password, and admin user and admin password. You can write these down. This is just for this demo. You're not going to get into my box. Okay. However, so these are global settings. This is when I need to talk to my database. These are the prefix code. Prefix code really is just, as I create shards and things like that, these are mine and they're prefixed with X. Okay. And then here's my username and passwords for working with the workload groups and shards and things like that, okay? All right, over on the configs tab, I created a new workload configuration, okay? The workload configuration, again, this is what? What was the workload configuration? Anybody remember? These are the boundaries that contain all my shards and all the information about those shards and about that workload group. For example, if I go in here and click on, right? Now, I think I could have done a little better because I named my workload group name the same as my global settings. Ignore that, right? You'll see how these differ, right? But these are my workload group configuration settings. So there's the ID, but I have workload group name. The shard type is range. And then here's the important things, right? That it contained to this workload group, the boundaries of all these shards, right? Target shard count. Right now, this is my target shard count. I have, when I create my initial shards, I get 4, but I can have no more than 10. Okay? Max tenants per shard, that means, I can only have 20 tenants. Okay? Per shard. Min shard size DB, and so I got only 10, and once I hit max shard size DB of 30, create me another shard. Okay? This is the metadata. DAC path. We are going to talk about this because this is important, right? How do you create your shards initially and things like that, right? So this is the DAC path. So what I did is I went and created a database, right? And then you guys familiar with DAC packs? You guys know what a DAC pack is? All right, a DAC pack it's a SQL Server term. It means I create a database. I can actually export that database as a DAC pack, as a unit of work. And a DAC pack contains just schema. So what's the right word for this? It's the definition of my database. It contains the schema. Now, they also have what's called a backpack, not to confuse things any further. A backpack, same unit of work, but it contains schema and data. Okay? We're just dealing DAC pack. We want schema. This is a new database. I didn't put any data in. I just want a DAC pack because when I partition my database or when I go create my shards, it says, take this DAC pack, because this is what DAC packs do. I can go and push that DAC pack out to multiple servers and multiple instances at the same time and create all my shards, right? So, and I can do that asynchronously. So from a deployment standpoint, I can create all my shards within just a matter of seconds because it does it asynchronously. So we'll see that in a minute, right? So this is my configuration. But then if you notice along the top, we have DAC pack options, servers, shard maps, and pointer shards. We're not going to talk about pointer shards, right? So let me go back, and I said, all right, so I needed to create a server, and it says, all right, I want to, from on-prem, just from this scenario, what server am I going to push all my shards to? Okay? So I define this is my local box, so I define that server. Okay? And then let me go back to configs, and say what I need to do now is go back into here and go into servers and say, I want to apply that configuration to this server. So basically I said, take this server and apply this workload configuration to this server. Okay? I could have created multiple servers and said apply this configuration to more than one server. Absolutely, yeah. So that's the whole point, right? Can I create multiple servers and apply those shards? In fact, this is the whole cloud thing, right? So I can, or even on-prem, yeah. So I can take that workload group and apply that across multiple servers. So I can apply those shards across multiple physical servers. We're actually going to get, how do you map the shards? We're actually going to get to that. Okay? Yeah. So let me keep going, and this should answer your question, okay? All right, so I've got my workload group. Oh, wait. Configuration. Hold on a minute. So there's my server, that one, right? So I've mapped that. I also have DAC pack options. So since we're using DAC pack, I'm not going to go through all of these, but since we're using DAC packs, this is all the options that you can apply to when you do a DAC pack. Like, hey, just include these block when drift detected, things like that. So all the options that you can do when dealing with a DAC pack, I'm not going to go through all these. But the key here now is this screen, all right? So again, let me go back to SQL. I have no shards yet, okay? But I have defined through here, here's how many shards I want, here's the max number of shards I can do, things like that, right? Now what I need to do is actually need to, step one, calculate my shard map based on that information that I defined in the configuration, okay? So here's what I'm going to do. And so, again, all this information is being stored in this JLA database. This is, I just call it JLA, right? It could be called anything. But there's all the, if I expand the tables node, right, there's my databases, there's my servers, there's my settings, my shard maps, things like that. So this is the configuration database. Make sense? Okay. So let's go back here. Right? What I need to do now is create my shard map. This basically creates a shard map based on the information in my configuration. So what I'm going to do, click Edit, and click Calculate Shard Map. Okay? So I'll go back to Shard Map. Oh, what happened? There it is. Okay. So there's my shard map, right? So there's my server, there's my catalogs. These are actual database names. Now, I haven't published this out yet, but what it did is here's my shard map, right? This is based on the 4 shards. There's my range, so -9 kajillion to -4 kajillion, whatever that number is. And then, so there's my 4 ranges. This tells me that as I start inserting data, it knows which shard to put that data in. Okay? So there's my shard map. All right, step 2 is I need to now deploy this shard map and those shards to the database server. Okay, so that's step 2. So let's go back and we're going to go Edit. Go back to shard map and click Deploy to Server. All right, so we'll give this a second. What this is actually doing is if we actually go over, that should be done. Scroll down, we'll click Save. Right? So I have no shard map, but if I go back here, I should have, in a minute, hopefully this will work. This is going to suck if I have to reboot. This is not going to be good. All right. I've been having SQL issues, and I apologize. Okay. Let me go back. So I should have, let me do this just to make sure. I need you guys to see. Oops, not there. Only my databases. Data, should I have? Yep, they're not there. So I apologize. I think I'm having issues. So what I'm going to do is, can I take 2 minutes and reboot here? Okay, I apologize. I really do. All right. This stinks really. All right, let me do this. So the steps are, so first I created the shard map while I'm rebooting. First, I created the shard map, and then I need to publish those shards to the server. So it actually creates those 4 shards. So SLK01, SLK002, 3, and 4, right? So at that point, I have my databases, but what I don't have now is I actually need to take that shard map and make that available to my applications. That was step 3, right? At that point, we're essentially done, and we can actually start querying, right? So when we...
What about physical distribution across multiple servers?
I'm sorry?
What about distribution across multiple servers? How's that?
In terms of distribution of...
Of the shards across actual physical servers. So if you had like 4 physical servers and 4 shards, would it distribute them across?
So this is what the gentleman asked back here, right? Was can I take and spread my shards across multiple physical servers? Yeah. So the concept is, and this is actually what the whole principle between of cloud sharding is that when I create a database, it goes on one physical server, and I create a second database, it's going on another physical server, right? In this scenario, just for simplicity of the demo, all 4 shards are going to go on the same server. But you could basically say, yes, I define 4 servers, and then put those different shards on different servers, right? So, but for the simplicity of this, I only have 1 server, right? But yes, the whole concept is, yeah, I want to spread that load out across multiple physical servers, so let me do that. So let me put shard 1 here, shard 2 here on different independent nodes, right? Okay, we're almost back up.
Sorry, another question.
Sure.
On your DAC pack or DAC pack card,
DAC pack, yes.
I'm assuming that's just basically a definition template schema?
Yes, because...
What the database looks like.
Exactly. So I was going to actually get to that. What it does is when I say publish, it actually takes that DAC pack from that path, and that's how it creates those databases, right? It says, boom, push this out here. So it uses that DAC pack, that template, to create my shard databases. Yes? How do I join across shards? So again, this is one of the things we're going to talk about when we do talk about best practices is, so you can't do, if I got a database here, you can't do cross-database joins, right? So this is, there's multiple types of fan-out queries, right? And one of the types of fan-out queries is what's called a aggregate and summary query, right? So if I need to query across shards, so I do my fan-out, right? But I can't say join from here, from this one to this one. So I may need to bring the data back internally into my application and then join within there, right? And again, this is not just this. This applies to any time. Because how do you do it? These are limitations of not the technology, but the limitation of SQL itself. How do I do join across, right? Across databases. All right, so let me go back. And let's start this again. Well, it's starting up. All right, so what we need to do is probably run this one more time. And what this does, what I'm going to show you here, is what this does is this actually uses, you guys familiar with Azure Queues and Azure Tables? To do this, what it actually does is I'm using local storage here, but it actually will put the process of creating those. Really? You're killing me. What's that? Yeah. So let me start the emulator then. So. Close that. Let me. How much time we got? I want to get through this. We only have 25 minutes left. No, actually we have 45 minutes. All right. Back to config. All right. Again, my apologies. Okay, so queues. This was a creation queue. So nothing there. All right, so I didn't get that. Okay, so I think we're good. Didn't get anything out there. All right, So what we're going to do is we're actually going to go out here now. Let's do this again. So we're going to go to shard map, edit, and we're going to deploy shards to server. And just for the purpose of the UI, we should be able to go back to queues here and look at shard creation, right? Say what's queued and what's not. Oh, this is going to... There we go. Done. Right? So what it did, you asked that DAC pack question. What it did is it took that DAC pack and said, really, it only took, what, several seconds? But took that DAC pack and said, deploy that DAC pack to these databases, right? So there's my shards, right? Shard 1, shard 2, shard 3, shard 4, okay? What I need to do, though, now is, let's go back to config and do step 3, which is, right, publish the shard map. So I created my shard map, but I need to publish that shard map so that my application is aware of my shards. So when I go to insert or select or wherever, and it says, take this ID, put it in this shard. Or if I need to do a fan-out query for insert or select, it knows about the shards, right? So step 2 is to publish that shard map. Which, when I do that, it'll say, hey, it'll replace this. So let me go edit, shard map, and publish shard map. Whoops, breakpoint. Okay. There we go. So let me just save that. Okay, so there's my shard map. Okay, so it knows basically there's the proposed. When I said calculate shard map, that was proposed, but then I had to deploy the servers and then publish it. Right, so there's my shard map. So at this point, I've got my shards and I'm ready to query. Right, so I've taken a lot of the concepts of IDs and shards like that. So I saw a hand.
The DAC pack which you created is for the whole database.
Yes.
Is it possible, for example, we want to put a customer table in one shard and order table in one shard and so on, we distribute all the tables. So do we create a separate DAC pack for all?
Yeah, you would. But so there's a challenge with that though too, right? If you at that point you lose. What do you lose at that? Anybody want to take a guess what you lose if you've got a table here and a table here? RI, right? And that goes to this gentleman's question, right? So you'd have to do some sort of joins, pull the data down, then do a join, and then, right? So again, not the limitation of sharding, but that's the limitation of putting a table here and a table here, right? You lose your RI. This was kind of one of the challenges currently with SQL Federation, right? Because you take your table group and so as your partition, right? You got your other tables over here and things like that, right? So that's a challenge. Well, they're still in the same, Federation member, your related tables might be in another database, right? So it's doable, but it makes a little more work, okay? All right, so now at this point, let me go back, okay? And, oops, nope, let me go back to queries, okay? Again, please do not get hung up on the UI. This is not an award-winning UI. I don't plan on winning any awards with this UI, but this is very simple. This is, and the concept here is, I've got a drop down, but I can have multiple, I can kind of have multiple workload groups, right? So I can have drop down of different workload groups. But here what I'm going to do is just very simple, is I'm going to say something like, and let me run through an example, then I'll explain the example. So I'm going to say something like, customer, actually let me do this. So remember these numbers, right? -9 cajillion billion to whatever. So remember these ranges, right? So I'm going to go to query. I'm going to say just customer 0000 pound 32. I'm going to say get tenant ID, right? So basically this just, what does this tell you? Anybody want to take a guess? What shard, right? So I could say based on this customer ID, what shard to go to, right? So I would just say this is going to tell me which, right? Again, this is an example, but so then I could say very simple, insert into user profile, values, bang, right? Scott Klein, get UTC date. Okay? So this knows that by doing that, what shard to go to, right? And it should insert it into any shard. Right, so execute non-query. Okay? Now, select star from user profile. There you go. Okay? So it said this goes into shard 1. Bam. And now I don't have to say select star from user profile where, right? It wouldn't put it shard 1 and then said I could just select star from user profile. Okay? Given that shard ID, given that tenant ID. Okay? Make sense? Yeah.
Do I have to specify shard ID when doing inserting, or I just can randomly say insert data to the user profile?
So in this, this is just an example. Typically, you should not have to, right? Because behind the scenes, what this is really doing is it's taking that customer and saying, and basically doing that same thing and saying, go to this shard, right? So the reason we're doing it this way, again, this is why I'm saying don't get hung up on the UI, because really, if you were to look at, I'll give you the sample database, not all the sample code. You guys can play with it, but what this is really doing is it's saying, so the reason I'm doing it this way is because I don't have identity insert turned on the tables, right? Because really what should happen is it said, this is just, here's a customer, let me get the tenant ID for which tenant to go into, right? Again, these are things where you should be looking at this going, okay, I understand the concept, how would I implement this in my environment, right? Again, this is the golden rule. This is, I've just created shard partitioning, right? Yes?
So would your application ever need to know what shard it's on? And if so, how would you find out?
Would your replication?
Your application
Oh, your application.
ever need to know what shard it's on when you're doing inserts or things?
That's the shard map,
Okay.
right? That's the purpose of the shard map.
How the entity framework working with those things?
So it actually works with this very well because this is coming off the entity framework.
Okay.
Yeah. All right, so you could either do the entity framework or standard .NET, ADO.NET.
If I using standard ORM mapping straight away, will you build the entity framework entity for it straight away, or you have to do some tweaks to make that work?
I'm not quite sure the answer to that. Let's take that offline, and I'll see if I can get an answer for you. Okay, and if you guys want to know the question, what was your question?
How the ORM mapping works with those things, normally have entity work.
Yeah, so how do you map the shard map to the ORM?
Yeah, that's right.
Right, is the question. Yeah, that gets a little tricky, right? So we'll take that offline. It shouldn't be that hard, and I can show. Basically, I'll show you the code. I want to get through this to make sure so we can show.
Sorry, Scott, one more question. I just want to be clear on that. Are you saying that behind that UI where you just select star from user profile, basically what it's doing is it's first interrogating the shard map, saying where do I need to go and query, and then go and
Yep.
query, all right, there's 4 databases, it's going to basically query each one of them.
No, not each one. No. So basically, it's going to take that customer ID, and based on the shard map, it's going to take that customer ID and say, okay, that's.
Because it's up there. That's the only reason. Because
That's the only, yeah, this is just visual for you. That's it, right? Behind the scenes, it's not going to interrogate every single shard. It's going to go based on that, basically tenant ID, I know what shard to go to. And that's found in the shard map.
So on that, if you're writing an application, would you need to first do that, find out what tenant I am working with, and then do the query?
Yeah, because you're saying if I need to query, or if I need to query, you're going to say, okay, I need to, based on this tenant ID, what, So it's, how do I answer this? I think that the simple answer is yes, right? You're going to have to go, okay, I know based on my shard map, it's in this shard, right?
If you're taking an existing application, you're going to have to go through and modify it.
A little bit, yeah. So, and the concept is, again, these are sort of things to think about, and so how do you apply these to make the least amount of work for an existing application? This is, I created a new database, created my DAC pack, there was no data in here, made it very simple for the example. If you're taking an existing application, how do we apply these same things to make the least amount of work? Yeah. Does that answer your question?
I think so, yeah.
Okay.
I'm just trying to get my head as well. So you're saying based on the customer ID, setting up the context that selectable is going to, or something like that, not context, but you sort of say tenant ID is going to be that, you don't have to apply that directly
Yeah, so the whole purpose of the shard map is to say, so that when I do something like this, it knows at any given time where I need to go. Remember data dependent routing? I know where to go at any given time to get this ID.
So if you change the customer ID or look somewhere else with a different tenant ID, you don't have to reapply that.
Correct. Yep. Yes. Apply. Yes. Yeah. When you mean apply that, apply.
Well, if you change the customer ID, that will change the tenant ID.
Yeah. So if I did, yes. If I did this, 33, right, and then said, I now get a 6, right? That means it's going to be another shard. So I should get. This is a demo, so hopefully this will work, right? Execute query. I should get no records back. Oh, I did get one back. Oh, and I know why. Sorry. So yeah, theoretically I know why. So this is a bug in the because I think I have configuration wrong. But this should not return any records because it knows that 6 gajillion billion is not in that shard. I'll explain why in a little bit. This is a bug. But yeah, so principally the first demo says go to this shard. If I change that, it now says go to this shard for this ID. This is shown today because there's a bug in my code. Okay. Yeah, this is one of those, you need to trust me on this. Right? Okay. All right, so we good so far? Okay. So let's get back to the slides real quick. Because I want to talk about now the more all-important cool stuff of, we got, okay. Let's do, oh, no, okay. Stretching? All right. I want to get to management. And so DAC packs and fan-out queries. Okay. So using DAC packages, this is just from a management standpoint. Hopefully you understand this. This is DAC pack is a SQL Server functionality that generate DAC pack off a SQL Server, allows the quick deployment of databases. So in this scenario, this is what it used to create all my shards, right? You can actually use this, so if you need to make a change. So again, one of the great things about this from a management standpoint is if you need to make a bunch of quick changes to your shards, you could say, okay, I've got this big script, I can run this big script against all my databases, or all my shards, or I can take my data, I can create a DAC pack, which at that point says, here's my deltas, and then run this again, and basically it will update all your databases. Right, very, very easily. So it reduces the complexity of your upgrades. So instead of going, okay, let me run this script against all my shards, let me just push this DAC pack back out and upgrade them all at the same time. Okay. Again, we can do this in parallel. You can actually, if you want to, the DAC framework API, so you can do this all programmatically. In fact, this is what this code's doing, is it's doing this all programmatically, so you have more granular control over how your DAC packs are applied and when they're applied and things like that, right? Let's talk about the parallel execution of queries, right? This is the pinnacle of sharding, right? I've got data spread out across multiple databases, and I need data from all these databases, right? So there's two types of fan-out queries. There's the aggregate and summary, or member. There's a member and then a summary query, right? Member query just says, let me go get all the data from the members, and then bring the data back, and let me. So let's say, for example, I say I need the top 10 salespeople for 2012, right? Well, my salespeople could be spread out across multiple shards, correct? So how do I get the top 10? Yep, get the top 10 from each one, bring those back, and do another top 10, right? But this is important because this allows me to say, now don't just me do one at a time, but let me parallelize those, let me fan out those queries, parallelize, using the task parallel library, .NET, let me parallelize my queries against all my shards, bring that data back at one time, so reduce the complexity, reduce the overhead, and improve the performance of my queries, right? So execute these queries in parallel. So as the number of shards increase, so does the probability of errors increase. Right? So if I got 100 queries, this is really depending on how you implement your shards. Again, I want to be able to reduce the number of errors and reduce the human input. Right? So let me programmatically scale these out and get my data, bring that back, and do like top 10s and things like that. Right? We want to strive towards zero or minimal need for fan out. Right? But I think this is going to be a difficult thing to do based on what we're learning, right? fan out's going to be critical depending on what scenario you're doing, right? So fan out query and DML must exist. So if I'm making a change, if I need to do an alter table, let me do that through a fan out query, right? Instead of applying DAC packs or things like that. But the DAC packs could be, I think DAC packs are very valid if you're doing like significant changes to your databases. Okay. All right. So let me do this. So let's talk fan out query. Okay. So let's go back here. Let me get rid of this. Oops. I didn't want to do that. Get rid of that. And let me say, now again, so let me just do this. Insert into, you see, your profile. And I'm just going to make this very simple, right? I'm going to say one, Scott. No, we'll just do this again. Let's just say Chris. Get UTC date. Okay. So notice I have no tenant ID. I'm basically saying insert, right? So let me execute that non-query. Make sure I got my syntax right. Yep, incorrect syntax and error. Do this again. Yeah. This is what happens when you... You're supposed to catch that. All right, let's do this again. Anybody know what I had wrong? I have no idea. I have to type it again. All right, queries. Nope, queries. All right, insert into user profile. Oh, values. Is that what I did wrong? One, Chris Klein, get UTC date. All right, SQL people, does that look correct? Yeah, everybody's going, yeah, looks fine. All right, do this again. Okay, so now, there you go. So I just did a fan out query, right? Just did an insert fan out query and a select fan out query, right? Now, this is going to be kind of, I don't want to call this challenging because now again, don't get hung up on the semantics here because now I have the same record in all four shards, right? Don't get hung up on the semantic. The whole purpose of this is to say I just easily, based on what we just walked through, I just did a simple fan out query, right? Created my shards, did my shard map, and it said, let me just insert this record everywhere, right? So again, these are principles and concepts. So now we have this discussion is how do you apply this in your environment, right? How do you then say, now I need a shard, right? So what do I need to do? Do I take an existing database? Do I have a new database? Again, principles and concepts to say, how do I then take this, okay? I could, so we could still take this to the nth degree and say, all right, well, now I need to be able to say, all right, so do identities, and if I'm doing identities, when I create my shard map, I need to do my identities, and so, what do I do now when I have to split and merge? How do I handle those? Things like that, right? So there's a whole set of concepts that we haven't even begun to touch, right? This is just to get you thinking, right? How do I apply this, and how do I apply these principles to cloud database partitioning? From a transaction standpoint, so if I were to do a fan out, like this insert from a transaction, so it really depends on how you want to apply those where and how you want to apply those transactions. Because you can say, hey, if any one of these fails, roll everything back, right? So it depends on how and where you want to implement this. Again, so things to think about, right? So you could say, I don't care if the first one succeeds and the other fails, keep going. So again, it's up to you on how you want to apply transactions. Right? So I'm not trying to pass the buck, but again, it's up to you on how you apply this, right? Do you do it at the database level? Because every database is going to say, "Yep, I succeeded," right? So the first one could succeed and the others could fail. So is that okay for you, or do you use the transaction, the .NET transaction class, and say, all right, if at that point, if one succeeds and another fails, roll everything back, right? So it's up to you to determine how you implement that, right? Want to make sure I answer your question. Is that okay? See another hand? Okay. So does this make sense? Are we? Did I confuse anybody? Okay. Are we good so far?
I've just got one more question.
Sure.
Regarding best practice around the actual schema of these databases.
Yep.
It's kind of related to what you're talking about. Like you mentioned to the Jen just now, you lose your referential
Yeah.
entity if you take one entity and put it into one of the shards. What's the best practice? To have a whole database, but just with a smaller range right across?
So again, this is up to you, and that sounds bad because I feel like I'm passing the buck. But again, what I would not do, and this is the challenge that this gentleman back here said. It's really difficult, and this was, I think, one of the challenges with SQL Federation is that you could create a table group, right, and say, okay, here's my tables. Like think about the AdventureWorks database. You guys all familiar with the AdventureWorks database? What do you partition on? Because there's customers, orders, products, salespeople. What do you partition on, right? So if you partition on customers, right, you've got customers, all their related tables. So if you put that in a federation, that means that you're going to lose all the foreign key relationships to all the other tables. But that's in its own federation, so you can scale on that, right? So that was the challenge. I think one of the challenges with the federation is how do you do RI? Okay. Here we're in this example again. This is just to get your juices flowing, get you thinking. In this simple example, it's a very simple database. Has two tables. It has primary key. Has user profile, and I think it was blog, right? A blog table. Right. So very simple two-table database. Okay. In this example, to me, it's better to say I'm going to keep all the tables together, so I don't lose my RI, but I may have less tenants per database, right? To keep my database low. Right? And then I say, so this is the whole concept around the workload groups is to determine what's the best fit for me. How many shards do I have? What's my max shards? How many tenants per shard do I have? And what works best for me? Right? Does that make sense? Yeah, I would not, because it's difficult, and I apologize, but I would not try to, as best as possible, I would not separate tables and put a table in this shard and put a table in that, because you lose your RI. Right? It's doable, but you'd have to go query this table, query this shard, bring the database back, into a data set, do the join, and then do query and things like that, right? And just too much overhead. Because you have to basically bring all the data down and then do the join, right? That makes it difficult, way too much overhead. Okay? All right, so let me just wrap up here by talking about some best practices. Okay. All right. Some of this should make, do you use, and here's the problem. One of the things that one of the challenges we ran into is anybody here use GUIDs? Okay. What is the challenge around using GUIDs for a tenant? What's that? Index fragmentation. How do you sort, right? How do you do arrange in, using GUIDs, right? So, you could say you've got one side of the camp that says, hey, GUIDs are, here they are. So, is it on this one? So, GUIDs are 16 bytes, BigInts are 8 bytes, right? So there's cost savings there as well if you're using. So, kind of the not sure I would use a GUID as for a tenant ID type, okay? But you want to make most granular as possible. The smaller, the better. So if you can get an int or a big int, there you go. The key is, picking defining the tenant. It's not just the data type, but really, what are you partitioning on? And it could be, again, one of the exercises, go through like the AdventureWorks database and say, what am I partitioning on? And again, you can have multiple workgroup loads, so you can experiment with this in this scenario. But the key is you want to make it, you want the ability to say, what's my best tenant ID? What's the key that I'm partitioning on and what makes the most sense? Right? And that might take a little homework, right, to determine what am I doing. Because The sharding key typically equates to the tenant ID. So again, what am I partitioning on, and what is the best key for me to partition on? Okay. And again, so there's this gentleman's, right, 0 to minimal cross database requirements. This is, not to beat a dead horse, but you want to make sure that you're not doing any queries across, joining tables across multiple shards. Okay. And lastly, establishing tenant surrogate key, right? So this is used for all non-reference table records. Again, this is where the GUID is a common data type, but it's too large. Big N is better. It's half the size of the GUID, so kind of some best practices, right? As you're planning, whether you're taking an existing database, you're creating a new database, what's the appropriate key? There was a concept called table groups, right? These don't apply anymore, at least in this scenario, because we're taking the entire database and saying, what are we doing, right? And so you're also looking at that and going, hey, can I apply an int? And so as I partition across multiple databases, what's the key that I'm using, and what's going to happen if I merge, right? So one of the things you have to think about as you apply your DAC packs and create your shards is, can I use an identity? Can I use an identity? And what happens when I publish these out and start generating IDs? But then when I merge, what's going to happen, right? This is one of the big challenges with SQL Federation is you couldn't use identity in the inter-federation tables. But can you get away with that here? So again, what are you thinking about? Okay. So we got about 10 minutes left. Any questions? Yeah, so this is, again, so was this all right to start spurring some concepts and start getting you to think about how to partition, right? Absolutely, again, I want to make sure that this is not, we're not saying, hey, right, this is, golden cup, please use this. This is, if you're thinking about partitioning, how do you do this, right? And you don't want, what you ultimately do not want is a bottleneck, right? Right, and this is what you were talking about. I don't want to have to go here every time to figure out. I don't want to have to go to A to figure out every time to figure out where I'm going to be. Right, I should be able to easily change, and that's what the shard map is for. Right, so to easily partition my data and know where any given time where my data is and route that data appropriately. Right, I don't want that bottleneck. Even though the configuration database is there, it's only used for metadata, so I don't want that bottleneck. Did I see a hand? A couple of them. Yeah, go ahead. I'm sorry, ask that again. So yeah, the configuration is only stored in the configuration database simply for the to create my shards and create my shard map, right? The shard map, yeah, but that's in memory, right? That is in memory. Okay. So that way I'm not hitting, and so again, that also begs another question. So if I were to create another shard, you have to update your shard map. But again, that's easily doable because as you dynamically partition, read that shard map, and so update that shard map so your application knows where it's going. But all that's in memory. Huh? Well, okay, let's say you even had 10, 20, 30, right? It's in memory, so it's still going to be, even if you had 100 shards, right? That's small relative to hitting a database every time to figure out where I need to go. So let me go, this guy had a question, then I'll come back to you.
How would you handle schema changes? So release another version of the application?
Yeah, so we got to that, remember? So you can either depends on the size to me it's all dependent on the size of the data change. If I'm just doing like updating a table or altering a table or adding a column or something like that, I could go into that window and say alter table, blah, 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 right? Well, yeah, so this is where I could go alter table. Huh? Right, so I could do, no tenant alter table, and it would take that query and apply that to all the shards at the same time. Yeah. I could do, so there's two ways. This is one. If it's a minimal change, I would do this. If I'm rolling a new version, I've got significant changes. The DAC pack's your best friend. And reapplying the DAC pack. Yep. So that's a whole different, and I'll say if you want to, I can send you the information on that because you can do, again, we talked about versioning. You can do versioning on this and say, okay, now I'm applying this. So yes, you could create a new DAC pack and apply those changes. Right? I would do it that way if I got significant changes.
Where a query hits multiple shards, are you doing any dynamic query rewriting in this, or is it leveling you either fan out or you're targeting one shard in this framework?
I'm not quite sure I understand your question. So in this scenario, I've taken that one query and using the task parallel library to execute that one query against all the shards at the same time and bringing that data back and then aggregating the data.
So when you say select star from table, is it basically you either target one shard or all of them?
All of them. Yep.
You got to scale out the reason.
I'm sorry?
So it literally hits every node within the tree.
Yeah, so it basically hits, so again, when I execute this select star from user profile, it's taking that query and going to all 4 shards, executing that query against all 4 shards simultaneously, and bringing the data back.
If I specify conditions, so between 2 ranges, is it intelligent enough to automatically pick the shards?
So it depends on how you apply those shards, because you can, in this scenario, right? Again, what you can't say select where, right? Because how do you define your ranges, right? Since this is range partitioning, you could do, and again, it depends on how you do your UI. Again, this is a very simple UI, but you could probably create a UI that says, give me your, define my range, and go, where, give me a list of tenant IDs, and then it'll say, and it'll go out and query against those shards. Right? So again, it's based on how you implement. Does that answer your question? Yeah. So we can talk more after, because it's really, again, this is just a simple query go. But if you want to say I want to apply and go against just a couple ranges, how do you define that? Right, and that's again up to you. Okay. Along with replication. I think this is separate than replication, because since these are independent databases, you can certainly say, let me set up replication and replicate these databases from. Yeah, see that. So that's a good point. If I'm doing dynamically, you'd have to re-update your replication, right? So, doable, but a little more work for replication. And we'd have to, and at that point, I have to take a step back and chat with you about, well, why are you in replication, right? And what do you need replication for, and how do we implement, or how do we solve that, right? In this scenario, yes. And the best practice states, you want to have your tenant in so. Yeah, so at this point, it's not a requirement. Like you're thinking, I think of, so the requirement right now is no, your tenant ID does not need to be in every table, right? But I think, let me get a better answer for you. That I don't know, but I'll definitely find out for you, because I'm sort of on the fence, because you could do that, and then because as you partition, I'm thinking in terms of table groups. You wanted your partition key in every table, because that said, hey, I want to partition on these tables. But since our database is one big database and we're partitioning on that, I don't think it matters at that point. We're basically just partitioning the whole entire database. But maybe I need to understand you a little deeper. So let's chat after. Right? So it shouldn't be hard, because if you need to update your shard map, is that what you're talking about? Yeah. So in this scenario, it's not built in, but you should just be able to, once if you're dynamically creating shards, then you're basically in essence going back to. Let me go back up here. publish the shard map, right? So basically, and again, you could look at this code and see how we're doing that. But in essence, you should be able to dynamically say, as I'm rolling out, creating multiple shards, update my shard map and publish that shard map back out. So dynamically do that, right? So again, this is a simple UI that we're just doing this manually. But the principle's here that you could actually take this code and say, yep, I can do that dynamically, right? Yeah.
Earlier you mentioned aggregate and summary queries.
Yes.
Are they done within the database, or do you summarize in code?
So you could do those. The reason I brought that up is because that's the example I gave was select top 10 salespeople, right? So you need to go to, let's say you've got 10 shards. So you need to do a select top 10 against all those shards. So there's your member query. You need to bring all that data back and then do your aggregate and summary query to do it. Aggregate that data, and then do another select top 10. So you could do, I guess, I'm not going to profess to be a map reduce guru, right? But I don't think, from what I understand, you could probably definitely do a map reduce kind of scenario on top of these, right? This is just if I'm using straight, so the reason I brought this is straight SQL, right? If I'm doing straight SQL, it's my member query, bring the data back, aggregate it, summary query. Yeah, so yeah, you probably could do a map. And absolutely, so yeah, you absolutely could. MapReduce is, you could certainly use SQL as a data source for MapReduce, right? Interesting concept. Have to think about that one. All right. So any other questions? Was this helpful at all? I mean, yeah, a couple thumbs. All right. All right, good. So I wanted to make sure, again, these are concepts. I want to make sure that things to think about. We're starting to put some of these things together and drilling down and kind of finalizing kind of where we're going with this, right? So your feedback is really important. Tell me, hey, this is great, or this is, what are you thinking about this, and things like that. So if you have feedback, please, let me pull up my email address again. That one. Let me know. Email me, whatever. Just say, hey, have you thought about this? Give me your feedback. This is important to us, right? We want to make sure that, cloud's going to be around for a while, and this even applies to on-prem, but your feedback is really important as to, how are we thinking about, what are we thinking about, and how where are we going with this cloud database scalability type of concepts? And have we thought about this, and, what about this scenario, and things like that? If you're thinking about it, please email me and let me know, right? Yeah, so yes, we won't. I'm not quite sure when, but very soon we'll make this available. Email. It'll probably be on either my blog or it's part of the SQL Cat team, so either their blog or like CodePlex or something like that. So if you want, email me and let me know, and we'll see where we can make this available. Okay? Awesome. I appreciate your feedback and your chat. Thank you very much. Appreciate it.